So today we're going to be starting Chapter 3. In Chapter 3, we're going to be talking about the the sine, cosine, and tangent functions as in regard to like graphing. So what we're going to do is we're going to start with just how would I go about just naively graphing sine or cosine functions. So what I'm going to be using to do this naively is to just actually let's better do that. Is I'm going to be using the unit circle to generate points that I'll be plotting. So if I'm graphing like y equals sine x, the inputs to my sine function are angle measures, and the outputs are going to be the corresponding y coordinate from the unit circle. Is everybody good with that? So how many different ways do I have to represent an angle or to measure an angle? 2, right? I have radians or degrees. Which one do you suppose we're going to want to use if we're graphing? Radians. Why radians? If I'm going to graph 2 pi worth of radians, that's only like 6-ish units. As opposed to if I'm graphing in degrees, that's 360 units. So just as a space factor, it's much compacter to graph something in radians, and by and large, that's what we would be doing. Is everybody okay with that idea? Okay. So what I'm going to do is I just have this graphing software up here. I'm going to generate points from the unit circle, and then I'm going to plot those points using this graphing software, and we're just going to observe the shape that we get. Everybody okay with that? So my first x coordinate that I'd be graphing would be 0 radians, and the value for sine of 0 is 0. The next x coordinate I'll be graphing, or point I'll be graphing, has x coordinate pi over 6, and sine of pi over 6 is 1/2. And I'm just going to kind of continue doing this. So my next point would be pi over 4, comma, root 2 over 2, which is approximately 0.707. I'm just going to use a decimal because it's easier to type that in than a radical. Everybody so far feel okay with all I'm doing? Okay, I'm just going to speed up now and just type these in, because what I really care about is looking at the picture that I'm getting. I don't care so much about the numbers that I'm putting in. I want to talk about the picture that we're getting afterwards. Is that okay with everybody? What are you guys noticing here about our shape that we're generating? It's waving at you. Hi, it's me, the sine function. How are you? Very friendly, that sine function, huh? Okay, so that's the full unit circle that we just graphed. And if I wanted to graph more points, what could I keep doing? Just keep going around the unit circle, right? What's the difference now for the x's? I'd be adding 2 pi to each of these, right? And then my second time around, I'd be adding 4 pi and then 6 pi, etc. So what's the shape of this graph going to do? It's going to repeat over and over and over again, right? Because each time I come around, I'm going to have the exact same set of y coordinates for new x values, right? So if I look at the picture here, if I just graph the sine function, this is what it looks like. Let's now copy that in to our OneNote. So this is the graph for the sine function. Everybody feel okay with the picture that we got there and where that picture's coming from? So let's talk a little bit about this picture, or about some of the characteristics for the sine function. What's the domain going to be here? What's that? You mean all real numbers? Yeah. Which shouldn't be a surprise, right? If I can take the sine of anything between 0 and 2 pi, and I can make any angle of any size that's going to be, and every one of those angles are going to be coterminal something between 0 and 2 pi, then take the sine of everything. What is the range going to be, though? Yeah, so -1 to 1. And here's the big question for you. Should I be having brackets or parentheses? Brackets, very good. Why am I getting a bracket here as opposed to a parenthesis? Yeah, I actually have a point that has the y coordinate -1 and the y coordinate +1. Everybody agree with that? So those values are actually taken by the function, so they are absolutely included in our range. Those are values that the function can have. How about the symmetry? If I look at the picture here, do you guys see it? Recognize the symmetry going on there? What are the 2 types of symmetry we talked about? Well, actually 3. X-axis, y-axis, and then 180-degree point rotation about the origin. Which one of these was this? Yeah, the 180-degree rotation about the origin. Also known as odd. That's what I'm going to call it. And then to show something was odd, just as a reminder, f of -x should equal -f of x. And then continuity. So if I look at my sine function, do you guys see any discontinuity? Do you see any vertical asymptote? No. Do you see any jump discontinuities where the graph is broken into two parts? No. Do you see any removable discontinuities? Is there a hole anywhere in the graph? No. So what does that tell you? Continuous everywhere, right? Over its entire domain, and since its domain is all real numbers, we'll just say continuous everywhere. Now, I want to take a moment and talk about, four new pieces of vocabulary that we're going to use to describe what the graph of a sine or cosine function looks like. So the first attribute is called the midline. And the midline is going to be a horizontal line that divides the graph in half. If I look at this graph of sine, where does the midline appear to be? Y equals 0, right? The x-axis. Because I have the same amount of graph above as I do below. Right? Everybody agree with that? The next one we're going to talk about is the amplitude. So the amplitude is the distance from an extrema to the midline so like that's an example of an amplitude. How far is that? That's 1 unit. What's another way you could describe the amplitude? You could say half the distance from a max and a min, the lower bound and upper bound. So again, the lower bound's at -1, the upper bound's at +1. Half of that distance is still 1. It's this different way of saying the same thing. Either is okay. The third thing is the period. So the period is like the longest non-repeating segment of my graph. So let's say we start looking at 0, 0. So if I look at my graph, I have an up, and then I have a down, and then I get back to 0, 0, and I would do another up again. I picked a terrible color to do this with. Maybe we'll do blue. Right? And then there I would start going again. Would repeat. You guys all agree with that? So this horizontal distance is the length for one period. How far is that? Yeah, very good. So we start at 0, we ended at 2 pi. So that period is 2 pi. Okay. And then the fourth thing I want to talk about, or new thing I want to talk about, is the frequency. The frequency is the number of periods per 1 unit of length on the graph. So by definition, the frequency would just be 1 over the period. So in this case, just 1 over 2 pi. Everybody's okay with what those 4 new terms are kind of saying, what they mean? How to look at the graph and find them? Okay. Let's do kind of the same process here, but let's do the cosine graph. Get that guy down there. Get you out of there. And I need to go back and look at my unit circle here. Now, the process that I used before is going to change just ever so slightly, right? What's the only difference going to change? The outputs, the y-coordinates of the point I'm plotting, are now going to come from the x-coordinate on my unit circle. Everybody agree with that? The inputs to my function are still going to be angle measures. They'll be exactly the same as sine was, but the outputs are now going to be the values for cosine of that angle, which is the x-coordinate from the unit circle. So I'd have 0, 1, pi over 6, and square root 3 over 2. That's about 0.866. And then square root, or pi over 4, square root 2 over 2. And then pi over 3 and a half. And then pi over 2 and 0. And 3 pi over 4, or 3 pi over 4, 2 pi over 3 and a half. And then 3 pi over 4 and that, okay? Oh my goodness, Mr. Kulik, what are you doing? What's wrong here? It's negative 0.5. And then negative there, okay. Ugh. Boogers, I did it. I was doing so good. I have to remember press down and not enter. And the typer in me has got like programmed the wrong way. I got it now. I promise, guys. I'm in a good groove. Now I got it. Now I got it. Here we go. Okay. What is this point here in the wrong spot? What is that? Oh. What is, oh, that's why. This is supposed to be 3 pi over 4. There we go. It's like, what is going on? There we go. All right, sorry. Okay, let's get this out of the way. So there's my cosine graph, right? Everybody's okay with that? And everything that we observed about the sine graph, how it's going to repeat over and over and over again, is true for the cosine graph. Yeah, if I'm typing things in the right place. So if I graph the cosine function, it'll look like this. Drop that in there. So if I go look at the sine graph and the cosine graph, what do we notice right away about the relationship between the two? They're not opposite. They just look shifted left or right a little bit, right? And since it's repeating, you could either shift it left or shift it right, and you'd end up with identical graph, right? It doesn't matter which way you do your shifting. It don't matter how much you shift to the left or shift to the right. But like you can get it to line up exactly like the other one just by doing one or the other. Everybody kind of see that? Okay. So let's say the same things now about our cosine graph here that we did about our sine graph. What's the domain here for a cosine? Yeah, it's still all real numbers. And the range, -1 to 1, which shouldn't be a surprise, right? If it's the same graph, just shift it a little bit left or right. And my symmetry here, what kind of symmetry do we have? It's not odd. Yeah, this is symmetric about the y-axis, right? If I look at this half of the graph, is a reflection of this half of the graph, right? That was what we called even symmetry when we're symmetric about the y-axis. And to show something was even, again, you want to show f of -x is equal to f of x. Just squeezing a little bit of that review in there, connecting back to chapter 1. Continuity, still everywhere continuous, right? Obviously, if we said the sine graph was everywhere continuous, and this is just like, looks like a horizontal translation of the sine graph, if that was continuous, this has got to be continuous. So like, well, what are we talking about, Mr. Kulik? Good observation, student. All right. Let's talk about those three now attributes or descriptors about our graph. What's the midline going to be here? Still y equals 0. Just as an aside here, if you write 0 for the midline, is that okay? No, Mr. Kulik would mark that wrong. You have to write y equals 0. The midline is an equation for a line, not a number. 0 is a number. Y equals 0 is the equation for a horizontal line. So just to let you know that I will be picky about that, because communication is important and you're clearly not communicating the right information if you just tell me it's a number and not the equation for a line. Okay? Just to be clear. I don't want to feel like you got tricked or anything, so let's point out that there is a difference between writing those two things and that I will be picky about that difference. Amplitude. Still 1, right? If all we did was shift left or right, that distance from the extrema to the midline still has to stay the same. If I'm looking at the period, what's the period going to be? Still has to stay the same, right? If I just shifted left or right, if I start at a peak and I go to another peak, I start at 0, went to 2 pi, it's still, one period is still 2 pi. Everybody agree with that? Traveling peak to peak. And my frequency then still is going to be 1 over 2 pi. Is everybody okay with how I generated these two graphs kind of naively? Now we're going to, when we go to actually graph these things in practice, we'll talk about how we would do that in practice, and we're not going to be like pulling all the values from the unit circle and plotting them. But I want to show you just like the relationship between the unit circle and the points on these functions. Everybody okay with that? Just as an aside here, functions like sine or cosine that repeat over and over again, these are called periodic functions. And specifically sine or cosine graphs or sine or cosine functions are referred to in general as a sinusoid, is the technical term for the class of functions that are sine or cosine functions. They're all called sinusoids. So just a little bit of vocabulary. This gets used pretty frequently in instructions like graph the sinusoid, and just it's easier than saying the sine or cosine function, just to say sinusoid. But that's all it means. Everybody okay? All right. Now I want to think back to section 1.8. So recall in 1.8 we talked about a parent function and then a resultant function, where that resultant function was a transformation of some parent function. Mr. Kulik, should I have those like general forms memorized? Yes. Yes. Please, please, please do. So, what did A do again? Vertical stretch or shrink and a reflection across the x-axis. What does the C do again? Flip across the y-axis or horizontal stretch or shrink. What does the H do? Shift left or right. And then what does the K do? Shift up or down. Okay, just as a reminder. So what we can say then is we're going to take our two new functions, sine and cosine, and say, okay, well, any sine function I can write as a transformation of that parent function, and any cosine function I can write as a transformation of its parent function. And now let's think about, for the resultant function, what's its domain going to be? So I could stretch or shrink or shift up and down, left and right, reflect. What would the domain be? Still all real numbers, right? If I do any kind of stretching, shrinking, shifting, reflecting, the thing was covered the entire x-axis before, no matter what I do, it's still going to cover the entire x-axis now. There's no way that I can do one of these transformations and like break a piece off and like remove a piece from it or something. Like, you just can't do that with the types of transformations we're talking about. So if the domain was all real numbers before, it'll remain all real numbers now. But what about the range? The range was -1 to 1. Will that change if I do a transformation? Yeah. What things could change the range? A and K. Very good. So if I vertically stretch or shrink it, the highest possible points would get higher or maybe lower, right? And the K is going to shift up and move the y coordinates to totally new locations. So the range would be, in general, is you've shifted up, and then you would subtract off the new maximum height. Yep, and I'm putting the absolute value there because the A could be positive or negative. But that doesn't really matter, because if I reflect it, just the low point was the high point, and the high point's now the low point, but it's fine, you know, like, but I need the low number first when I write my range, right? If I write an interval, it has to go lower bound, comma, upper bound. So this way, using the absolute value there ensures that the smaller number will always be the left input or the left position in my interval. And that's the same for sine or cosine because they both had the same ranges. I'm going to skip symmetry. Why am I going to skip this? Can a transformation change the symmetry? Oh, you betcha. You betcha. In fact, it's probably going to destroy the symmetry more often than not. And you're left with no kind of symmetry. So it's not even worth talking about. Continuity? Can't change that though, right? If the domain stayed the same, the continuity has to stay the same. So I'm not going to bother with that or writing that down either. Well, okay. Fine, you got me, same. Okay. Midline. Can a transformation change the midline? Yeah, absolutely. What AH, ACH, or K is going to change the midline? K. Just picking it up and moving it up or down will change where that middle of the graph is, right? So the midline was y equals 0. So now it's going to change to y equals k, since k is an additive operation, right? It's plus k in the function. So it'll just be 0 plus k. Everybody's good with that? The amplitude. What's going to change the amplitude, AC or H or K? The a vertical stretch or shrink, is going to change the distance from those extrema to the midline. Everybody agree with that? And it's going to change both of them the same amount from the midline, right? So the amplitude and the A in our function, is the A being added or multiplied? Multiplied. So the amplitude was 1 before. So now it's going to be absolute value of A. Why am I putting absolute value around this? If A was negative, amplitude's representing a distance shouldn't be a negative number, right? It's the distance from an extrema to the midline. So just going to slap an absolute value around it to take care of that. Period. What's going to change the period? A, C, H, or K? Or maybe nothing. No, it did. Something changes it. C, right? If we have a horizontal stretch or shrink, the length of that one cycle would get shorter or longer depending on whether you stretch or shrink. Everybody's okay with that? Is the C multiplied or added? Multiplied, so it'll be multiplied here. And remember, the period is a distance, and the C can be negative, so we're going to slap in absolute value around that C. Everybody's good there? And then the frequency is still going to be 1 over the period. Now this, Mr. Kulik, should I memorize this? Yes. Yes, you'll want to know this. And now, when we talk through it, hopefully I talk through it in a way that, like, it's easy to remember it, because we tried to connect it to, like, it makes sense why the values are what the values are. But at the end of the day, you need to know it. Okay? I prefer, like, you understand it to memorize it, but, like, make no bones about it. Like, you need to know how to get these values from your A, C, H, and K. So let's take a moment and do some practice on that. Okay, so I'm just going to give you guys a couple of sinusoids, and we're going to determine the domain and range and midline, amplitude, period, and frequency. I'm just abbreviating domain, range, midline, amplitude, period, frequency. Because quite frankly, that's a lot of letters to write out. I just didn't want to do it. Okay. The way we want to start, the first thing I need is to come up with the values for A, C, H, and K. Looking at my graph, or looking at my equation, I should be able to read the values from this. What's the value for A? -4. What's my value for C? Okay, so remember, we have to think about it in that general form. So again, there's that. So here, my 2 is 1 over C. So regular C has to be 1 over 2, 1/2. Everybody's cool with that? What's the H? 0, because there's nothing added or subtracted inside my function. And the K is 1. Okay. So my domain is all real numbers. That's easy. It never changes. What's my range? I know it's a bracket, and it's K minus the absolute value of A, comma, K plus the absolute value of A. So that's -3, 5. Everybody happy there? Okay. What's my midline? Y equals K, and in this case, the K is 1, so just Y equals 1. Okay. What's my amplitude? 4. Again, that's the absolute value of A. So the absolute value of -4 is just 4. Okay. What's my period? Pi. Very good with that. So the frequency then is 1 over pi. Well, that's not so bad, Mr. Kulik. Yeah, it's not. But you got to remember how to find those things. I'm going to do a couple more examples because I want to do some sneakier things that I still fooled most of us on when it came to the last couple of test questions that were repeats from chapter 1. So I want to make sure I do a couple of examples where I can point out the thing that I keep tricking you on. Okay. All right, so we'll start same way. Find our values for A, C, H, and K. My value for A is 2. That's good. The value for C is -1. The value for H is well, remember we have to write it in that general form. So I notice that the coefficient here on x is 1. The coefficient here is not 1, so I have to factor that off. So the value for h should be positive pi. Oh, Mr. Kulak. Gotcha. Does everybody see the trick that happened? Got to get it into that factored form before you can tell what h is. I think the vast majority of you guys, I still tricked you on the last exam, or the last test on the describe the transformation question, because not a lot of people factored to find the value for h, and I snookered you guys again. Don't let me trick you, though. I'm showing you my tricks, my best tricks. I'm going to show them to you. Don't get fooled again, like the Who song. That's before I was born, so I don't know why I made that joke. It surely did not resonate a bit. I don't know that anybody even recognized it, that it was a joke. Domain, still always all real numbers, right? No concerns there. What's the range going to be? -2 to 2. Very good. So 0 minus absolute value 2, 0 plus absolute value 2. The midline is y equals 0, not just 0. I would have said wrong, but you caught yourself. Good job. The amplitude is 2. Yep. The period is still just 2 pi, right? And so the frequency is 1 over 2 pi. Well, that was pretty easy, Mr. Kulak. Yeah, well, you can negotiate the tricky piece then. Should be pretty easy. All right, one more. Start in the same way. What's my value for A? 1. What's my value for C? 2. Everybody good still? What's my value for H? Not 3 pi. Mr. Cook, there's not even a 6 in there. Where the heck is that coming from? Because you have to factor to make the leading coefficient on x 1. So I have to factor that 1/2 off. When I take 3 pi and divide it by 1/2, I get 6 pi. Ugh, Mr. Kulak. Got to be careful. I wouldn't go about finding those values for A, C, H, and K until I've gotten it written in the, in this kind of standard form. Is that okay? Everybody still doing all right? You feel like I'm showing you the good stuff? I'm giving you the goods? Like, what are the weird things that can happen? Like, show me the stuff that I'm going to get wrong so I don't get it wrong and get in the future? I'm trying. And then the K is -2. All right. So my domain is all real numbers. My range will be -3 to -1. K minus absolute value A, K plus absolute value A. We good? Midline. Y equals -2. Amplitude 1, absolute value of A, period, not 2 pi, 2 pi times absolute value C, which would be 4 pi, right? 2 pi times 2. And the frequency, obviously then 1 over 4 pi. What do you guys think? Feel okay with identifying these values from the equation now? Be okay. Just takes a little bit of practice. They're pretty easy to remember. So we're going to talk now about graphing. What you want to remember, or the way we're going to be graphing, is we're going to use this. This function map from 1.8. Mr. Kulik, do I have to have that memorized? Oh, you definitely want to. The question for us is, what points am I going to be using? Is Mr. Kulik going to ask you to use all the points from the unit circle? No. In fact, I made up a handy sheet for you that has the points that I'd like you to use. I'm going to call these the reference points. So this is in OneNote. It's called reference points. So these are the 5 that we'd use to graph the sine function. These are the 5 that we'd use to graph the cosine function. We're not using all the points from the unit circle. We're just using the quadrantal angles, the angles that lie on the x or y axes. Why am I choosing to just use these ones? Because these points are either x-intercepts or the extrema. And that's going to be able to give me a good picture if I know those. I can connect everything in between if I know what the shape generally looks like. Is everybody okay with that? Okay. I'm going to go back and erase those because nobody needs those marks on the sheet that you're potentially going to copy and paste and use all the time. All right. So let's just go back and take maybe yeah, I'm just going to use this one that we just looked at. So the first thing I'm going to do is I'm going to identify the values for A, C, H, and K. I'm just writing these down because this is the same example we used prior, right? So I'm not going to pause and explain that. I'm then going to write out my function map, or my transformation map, maybe I should call it. And because this is a sine function, I'm going to use the points, the sine points from my reference points table. And I'm just copying these down. Mr. Kulik just doesn't need to look at them because, well, he's been teaching this mathematics for like 15 years, and he's got them super memorized because literally it's like you've been taking the same class for 15 years. Think about how good you'd be at doing trig if you had to do this every year for 15 years, and you had to be good enough at it that you could sit here and talk in front of people the whole time doing it. You'd be really good at it. So that's Mr. Kulik just has these memorized. All right, so what am I doing? I'm just plugging like 0 in for x, and then plugging the 0 in for y. Everybody's cool? And I'm just going to kind of continue grinding my way through doing that same thing. So it's these points that I'm going to be plotting. Ooh. Maybe make that a little bit higher there. Okay, so I'm going to drop in some graph paper. And then I'm going to plot my points. So 0, 1. And then pi over 4 is like 0.25 pi. So that would be like right there. And then -3. Then I have pi over 2 and 1. So pi over 2 is like 1/2 a pi or 0.5 pi. And then I have 3/4 pi, which is like 0.75. And then 5, which is like up there. And then I have pi and 1, so like there. So if I graph this then, I get something that looks like this. Everybody okay with that? Now, on a test or quiz or homework or whatever, Mr. Kulik is going to ask you to fill the space provided on your graph paper, or he's going to tell you a specific like width to draw your own picture that he wants you to fill. Now, am I going to keep generating points and like grinding them through the formula? No. I'm just going to follow the pattern. So I'll make my next tick mark. The next tick mark should go down to the minimum. The next spot should be back at the midline. And then in the next spot would be the maximum, back to the midline, down to the minimum, back to the midline, and I'll just kind of just trace that in. I'm going to draw this with like a dashed line so you guys can see that I'm just extending. Certainly. And I'm going to extend in the other direction also. So the next spot here would be up to the maximum, and back to the midline, then down to the minimum, and then back to the midline, up to the maximum, back to the midline, down to the minimum, back to the midline, up to the maximum, back to the midline, and then we'll just kind of connect everything. And there's my picture that I would say, great, that looks wonderful. What do you guys think? Is this fairly easy, right? The hardest part is really getting the correct values for the A, C, H, and K. That's the part that's the easiest to screw up. From there, it's just kind of grinding through the formula to get your points, and then plotting your points on your X and Y axis. You make sure that you're paying attention to the scales, right? So like all of my points were in terms of pi. All of my x-axis, the tick marks were all in terms of pi. That should always be the case. Okay? This feels like a good place to stop for today. We're only halfway through section 1. So there's another set of ideas that we're going to deal with in section 1. But at this point, you should be able to do 1 through 6, and then 9 through 12, and worksheet 1. That should all be doable for you guys. Is any of that due this weekend? No. What's due this weekend? The rest of chapter 2 stuff. So like the last 10 questions from the problem set, the worksheet, and the review, I think is what's due on Sunday. Most of us probably have that all done already because usually we finish the homework before we take the test anyway, so that's a relief. If not, you just probably have a couple of things to kind of put the finishing touches on or whatever, but probably most of us are all set with the Chapter 2 stuff. Considering you just took the Chapter 2 test this week, you probably finished all that stuffs.
Can I use a bathroom?
Certainly.
Thanks.
No problem. Anybody with questions for me about anything? This feels like a good stopping point, so we'll stop here.